We are from Infosys. My name is Dipali Deepak. I belong to the customer service group at Infosys. I have Madhav Apte with me, who's part of the asset management, who's going to be talking about the asset management solution based on RAMS modeling out here. We have heard a lot about, okay, I need to be close to this guy. We have heard a lot about operational efficiencies, analytics, digitization, and transformation today. I would like to ask Madhav to focus on engineering aspect of the conversation. So what about engineering data? And what about the tribal knowledge? What is it that brings all this together?
Sure. Thank you, Deepali. Thank you all for attending this session. So, as Deepali asked the question, in the previous sections we have looked at automation, digitization, transformation, predictive analytics, right? You look at individual asset, you model that asset, then you look at digital twin, right? So what, right? You have a pump, you know that pump, you can model the pump, and you know while it is operating at a margin, and you can predict based on the operating parameters that the pump will fail, say 6 months down the line. You can predict that with, let's say, 70% confidence level. Go closer, you can say that it will fail by 90% confidence level, right? But that's one pump, correct? So what? A plant is not based on only one pump. It's a system of assets that are interrelated, interconnected, and all of them are operating, right? So there is a dynamic relationship there. That's part number one. Part number two, there is engineering data that also needs to be looked at along with the operating data. That's part number two. Third, there are operators in the plant who have a very good understanding of each of the equipment and their interrelationships. So even if a given pump is operating at 90%, the operator may still look at another set of equipment and say, okay, this can operate at 90%, it will not fail. That's the tribal knowledge that resides today in every operator's mind. How do you bring all of this together, right? That's the challenge. And what we are presenting here is a framework that Infosys has developed called KRITI, KRITI. It includes your tribal knowledge. You can codify the tribal knowledge. You can connect your engineering data and operating data. And that's the framework this KRITI does. In this case, we are going to show a demo. We are looking at a wastewater plant and a pump, and what happens when that pump fails, and what does the operator do? So can you please play the video?
Wastewater units due to repetitive pump failures in the 4 years since installation. The failures have resulted in higher running costs and reduced production with the constant threat to the environment due to effluent overflow. The management has experimented with various asset management systems across different plants, but none help to proactively detect and avoid failures. The management of the enterprise decided to deploy KRITI 4.0, an AI-based RAMS framework that uses a model-based and data-driven technique, co-developed with expertise from Pori, Infosys, and Nokia. KRITI 4.0's RAMS model defines the plant's asset interconnections and their influence on the system's performance, identifying critical assets and their failure modes. KRITI 4.0's machine learning environment digests all the existing technical documentation, historical process data, real-time plant data, and information from O&M logs, along with tribal knowledge from experts, to create its knowledge and forecasting models and predict failures. 9 months into deployment, KRITI 4.0 progressively learned the system's behavior and adapted its models based on past failures that had occurred in the pumping unit. Recently, based on the learnings from the past failures and real-time data patterns, KRITI 4.0 notified Alan about a future failure risk in one of the pumps with a moderate risk level and recommended a maintenance date. Alan used the drill-down capability of KRITI 4.0 to decide on the new maintenance date by looking at the forecast pattern. Within the next couple of days, KRITI 4.0 came up with another proactive recommendation for a different pump failure, elevating the risk level to very high. KRITI 4.0 also escalated risk classification to human, business, and environmental in case both the pumps failed together, recommending Alan to fix one of the pumps immediately. Kriti 4.0, in the meanwhile, interfaced with the Enterprise Asset Management System, checked on the inventory backlog, and triggered a work order for spare parts to carry out the pump maintenance. Alan's maintenance team used the Kriti 4.0 chat box to identify the root cause of the problem. The QR fault code generated by the platform helps the maintenance team to use Kriti 4.0's Smart app that provides enhanced 3D modeled augmented reality-based steps for fixing the problem, reducing the mean time to repair by 30%. Kriti 4.0's dashboards provide Alan with a complete plant-level forecast of availability and safety for 90 days, along with the risk index, which is derived from the health of individual systems, underlying assets, and availability of necessary spare parts to carry out the repair. Kriti 4.0 also provides Alan with a view of his most troublesome assets and the nature of their failures. The unique framework is powered by Poiri's expertise in plant design and O&M, required to build and maintain RAMS models. Real-time information from the plant's control systems are acquired by the Infosys IoT Gateway and transferred to the AI platform using Nokia's secure connectivity. Nokia's Impact IoT platform and private LTE and Wing platform provides pervasive connectivity with embedded cybersecurity, ensuring reliability and security to the data. Infosys' AI platform uses multiple different techniques to decide on the right model for forecasting and predicting anomalies. Kriti 4.0 updates dynamically the different models based on learning and knowledge acquired from the plant operations across the enterprise. The constant updates help Kriti 4.0 become more proactive and consistent in identifying anomalies and alerting the users. Based on Alan's recommendation, the management has decided to deploy Kriti 4.0 to all the plants at the site and to expand it to other sites across the enterprise. Kriti 4.0, the innovative AI-based framework, using state-of-the-art technology to help enterprises remain competitive in the market by reducing cost, increasing productivity, improving safety, and reducing risks across assets. Kriti 4.0, an AI-based RAMS framework that uses model-based and data-driven technique to deliver results.
We finished early, we wanted 2 minutes if you have any questions. So we have used this in various industries, of course, utility, power generation, and paper pulp mills. So this actually can use your existing platforms and existing systems. It can connect to your existing asset management systems. If you have reliability, RAMS, by the way, stands for reliability, availability, maintainability, and safety of an asset. So almost all the engineering departments will have reliability teams. We can make use of those models that are already built and then use the Kriti framework to build on that. So we are at booth number 19. If you have any more questions, do let us know, or we can visit us and we can talk more.